All right, let's get right into it. We're talking about a super high-tech facility called Node 5. And its mission? Well, it's to go to one of the most challenging energy environments on the entire planet. And not just survive, but to learn, to adapt, and then to teach everyone else. This is the story of what they call the University of Energy.
But first, let me ask you a crazy question. What if a blackout was actually profitable? I know, it sounds nuts, right? A moment of absolute crisis for millions of people is usually a massive liability. But what if a system could be designed to look at that crisis, not as a risk, but as a huge financial opportunity? See, this isn't just a thought experiment. It's the actual business model of Node 5.
So to understand how they pull this off, we have to start with the location where this whole experiment is unfolding, Texas, and its famously fragile power grid.
Now, the key word to understand here is island. You see, unlike pretty much any other state, the Texas power grid, which is called ERCOT, is almost completely disconnected from the rest of the U.S. This independence makes it incredibly vulnerable to shocks, like a sudden deep freeze or a brutal heat wave. For most people, that's a gigantic problem. But for this project, it makes Texas the perfect real-world laboratory. It's like they're playing on hard mode on purpose to test their tech.
And you gotta understand, this lab in Texas isn't just some standalone project. Nope, it's actually a key piece of a much bigger, global strategy.
The company behind all this is called D-Reticular, and their big idea is something they called the sovereign stack. The whole point is to build the tech that lets a community or a factory or even a college campus operate in island mode, meaning it can run completely on its own, totally self-sufficient and independent of a national grid that might be failing. And the grand plan to make this vision a reality is called Project Octagon. You can think of it as a network of 8 specialized hubs, or nodes, that are spread all across the globe. Each one is designed to stress test a different piece of that sovereign stack in a totally unique environment.
And this really shows you just how big their ambition is. You've got nodes in Uganda handling logistics and green energy, another one in Canada that's basically the software brain of the whole operation, and a couple in Arizona testing tech in that extreme desert heat. But the one we're zeroing in on today is right there in the middle, Node 5, the energy student, located in Texas.
So let's zoom in and meet the star of our show, Node 5, the energy student. So what is this place? It's an urban energy lab. And what's really fascinating is that they strategically moved it. It actually started out in the freezing cold of Minnesota, where it was testing something called tundra mode. But then they picked it up and moved it to Fort Worth, Texas, specifically to get a front-row seat to the most volatile energy market in the developed world. It literally went looking for a challenge. Now, Node 5 also has a partner, something the project calls a digital twin. And that twin is Node 4, which is a huge green industrial park in Uganda. Now get this, they use the same core technology, but in wildly different environments. One is an urban lab in Texas, dealing with dry heat and a crazy grid. The other is a rural engine in the humid tropics that's generating its own power from waste. So you might be asking, why? Why run the exact same equipment in 2 totally opposite climates? Well, it's all about the data. By comparing how a battery or a computer performs in Texas versus how it performs in Uganda, they create this incredibly valuable data set. This data helps insurance companies accurately price risk for projects in Africa, it proves to manufacturers that their equipment is tough as nails, and it gives global investors the confidence they need to fund new infrastructure.
Okay, but how does Node 5 actually work day to day? This is where we get into the tech that powers this whole incredible experiment. First off, you've got the muscle. We're talking large, commercial-scale batteries for storing a ton of energy, a small plasma gasification unit that can turn local trash into a constant stream of power, and of course, powerful computer servers to process all that data. This hardware is what lets the lab just unplug from the grid and run itself anytime it wants. But the real secret sauce here is the brain, a specialized AI agent they've nicknamed the Trader. This AI is the intelligence behind the entire operation. It's constantly watching real-time energy prices, checking weather forecasts, looking at historical grid data, and then it makes its own financial decisions. When to buy power from the grid, when to sell it back, and when to just chill and run on its own internal power. This all feeds into its main strategy, energy arbitrage. It's a really simple 3-step playbook. Step 1, the AI buys electricity when prices are super low. Sometimes they even go negative in Texas when there's too much wind power. Step 2,
It takes that cheap energy and stores it in its massive batteries. And step 3, when a heat wave hits and demand goes through the roof, the AI sells that stored power back to the grid at a huge markup. Buy low, sell high.
And this playbook, this is the key to their entire financial model. It's how Note 5 is designed to turn the grid's biggest weakness into its greatest financial strength.
The facility actually makes money in 3 main ways. The biggest slice of the pie, of course, is that energy arbitrage we just talked about, but it also earns money from something called ancillary services, which is basically getting paid a steady fee just for being on standby to help keep the grid stable. And finally, it sells all that valuable comparative data it's generating with its digital twin over in Uganda.
But the number that really matters is this one. This is the maximum price cap for electricity on the Texas grid. During an extreme event, like those winter storms we've all seen, the price for a single megawatt hour can spike all the way to $5,000. So if you filled your batteries with power you bought for practically nothing, you can see how a single crisis event could generate enough money to pay for the entire facility. This quote from the project's own internal documents just says it all perfectly. The entire model is designed to transform the idea of grid fragility from something you insure against into something you actively invest in. The more volatile and unstable the grid is, the more profitable the system becomes. But remember, Node 5 isn't just about making a buck in Texas. Its most important job is right there in its name, the energy student, or as we've been calling it, the University of Energy. And this is all possible because of a technology called Federated Learning. It's the core of their global operating system, which is called RIOS. Basically what it means is that a lesson learned by the AI in one spot is instantly and automatically shared, or taught, to every single other node across the entire global network. What one learns, they all learn. So, for example, let's say the trader, AI, in Texas discovers a brand new, super effective way to trade energy. That strategy is immediately exported to its digital twin, Node 4 in Uganda. Now, Uganda doesn't have the same crazy market swings, but the underlying logic still helps that industrial park manage its own power way more efficiently, which maximizes its own revenue. Node 5 is the teacher for the whole world.
And that really brings us to the final, powerful idea at the heart of this entire project. It's not just about building systems that can survive a crisis. It's about building a future where being resilient, being self-sufficient, and being independent isn't just a backup plan, it's the most profitable strategy of all.